how can we get resolution better than the voxel size? The answer to this question is related to how exactly we define the surface. So let's think about this object. The cross section here looks like this, and let's zoom into this corner. So let's say that this is the actual cross section of the object. To image this using X-ray CT, we're going to use a voxel or voxel grid. And when you do that, you're going to get an image that looks like this. So the black part is air, and let's just call it 0% absorption. And the white part is the object, and let's call that 100% absorption. Then we have all those gray voxels in between. And we get those gray voxels because of the partial volume effect artifact, which we discussed in episode 6. And the gray level of those voxels can vary anywhere from 0 to 100. So how do we define the surface or the interface between black and white in this image? The simplest way to do it is just to threshold it at 50%. If you do that, this is going to be the surface and this is the object. Now, this doesn't quite look like the actual one. So we have to figure out a better way to do this. So instead of simply thresholding the image at 50%, we're going to take a probe and go from point A to point B. You cross the interface, then plot the gray value like this from point A to point B. Then calculate the average air level and average object level and figure out where the 50% line is. Then figure out where that point is on the line A to B. And mark that as the surface or the interface between black and white. And this point is here in the image. So you can see that when you do it this way, you are not bound by the voxel grid anymore. You can put the interface right in the middle of the voxel. And this is called ISO-50 surface determination. And you can calculate the average air or average object gray levels globally, but in many cases, the gray level can vary from part to part in the sample or slice to slice. So it works a lot better when you do this averaging locally. So we're just looking at a one probing, but you do this on the multiple spots on the interface to figure out the entire surface like this. So this is how you define the surface more accurately to do metrology analysis. And what we're looking at here is just a cartoon version of it, but let's take a look at a real example. So this is a part of a piece of plastic, and you see the yellow line, that's the defined surface. Let's zoom into one area. So those thin yellow lines are the probes to figure out the interface, and this orange line is the defined surface. And you notice that this line is running right inside of the voxels, and this is how you can achieve 1/10 of a voxel size resolution.